So, hello everyone. So, today in this lecture we are going to discuss the batch and continuous sterilization process. So, in the last lecture we discussed the kinetics of cell death. So, this was N equals N naught e to the power minus k d into T, and this k d specific date constant is independent on the T. We discussed k d follow Arrhenius equation, that A into e to the power minus activation energy upon R T. Then further we discuss the sterilization in terms of probability of extension, that is defined as 1 minus small p t to the power n naught, and small p t can be replaced by 1 minus e to the power minus k d t to the power n naught, where n naught is the initial number of cells. So, in today's lecture we will be discussing sterilization when it is performed in the batch, when it is performed in the continuous mode, and also we will briefly discuss about air sterilization, because both this sterilization of media as well as the air, particularly in the case of aerobic fermentation where it requires the huge quantum of air, the typical range of air supply is 1 ppm, volume by volume per minute. Now, first we will discuss the batch. So, as the name suggests, we are going to have media, let us say it is liquid, and that can be sterilized if it is there in a container by introduction of hot steam into the coil or jacket. So, if you pass the hot fluid in the jacket, it will increase the temperature of your media. In this way sterilization will be done. Alternative option is you directly bubble or sparge the steam into the media, and other alternative is you are going to have the electrical heating. So, what it says, you can have the jacket, where the hot fluid will enter into jacket and go out like this. Other option is you can directly add the steam into your media, and third option is you are going to have the electric heating. Now, in this case what happens, when you are directly sparging the steam, there will be increase in the volume of media, because whatever steam you have added, that will be condensed, and in turn it will contribute to total volume. So, direct steam, it causes dilution of media by condensate. So, it typical value is 10 to 20%, but it depends that what is the flow rate and time. Flow rate and how much time. And when you are directly sparging, then you need to really see the quality of this condensed liquid or the steam, particularly it should be free from any other foreign compounds, for example metal ions or some other organics. This we have seen, there are 3 modes, and once there are 3 modes means there are 3 steps. First is, you can just see the rising, this is the raw media temperature and this is the sterilization temperature. So, what did you see here? Rising the temperature of media to the sterilization temperature, this is the stage 1. Then next stage is holding at this temperature for certain time interval, stage 2. Then again you have to bring the back temperature to the room. There are 3 stages. Now, during the heating, depending on the whether this is a jacketed heating or electric heating or steam sparging, you are going to have a different trend. You can have the linear trend, you can have the exponential, and you can have the hyperbolic trend. This is time temperature graph. Then there will be holding, and further during this cooling again you can have the linear or exponential pattern. Now, how it is coming? Because we have seen in the first lecture the mode of heat transfer. So, if you see the heat transfer by the direct steam spurging, it will have the latent heat component as well. Now, next comes when we are heating, it will take some time. So, that is called T heating. Then you are holding for some time, this will be called T holding, and when you are cooling, this will be called T cooling. So, if you combine these three, this is called total time of sterilization. Now, according to this curve, if you just see, if you are going for heating, there is a slight decrease in the number of viable cell. It has decreased from N naught to N1, but you can see the maximum decrease is taking place during the holding time. It is exponential decrease from N1 to N2, and during cooling again there is a slight decrease in the number, and that number is N2 to Nf. Now, you can see the x axis the time taken for the heating, and number is decreased to N1, time taken for the holding, number decreased to N2, and time taken for the cooling, number decreased to Nf. So, in fact, we can write the same expression as we discussed in the last lecture, that minus dN upon dt equals kd into n, or ln nf upon n naught equals minus kd into t. So, what it says, ln nf and n naught can be splitted into three different groups. So, how it will be divided? So, I am going to write ln first. It is starting with n naught. Let us say we are starting with n naught, and it will go to the n heating. Then in the next step, it will start from the n heating to n holding, and the third stage, it will start from n holding to n final. Or you can quickly write, if I write here n heating upon n naught into n holding is the n heating nf upon n holding. So, ultimately I will end up with nf upon n naught. So, this nf upon n naught, now it can be split into three different terms to calculate the time required for the heating, time required for the holding, and time required for the cooling. So, in this way you should be able to get the either the number n0, n1, n2 and nf, or we can also find the t, time heating, t heating, time holding, or time cooling. Now, next is the continuous sterilization. So, this is also known as high temperature and short exposure time of sterilization, and it achieves almost complete sterilization and less damage to media because the time is short. So, how it is achieved? It is achieved by rapid heat up and cool down, and as it is a continuous process, then it has certain advantage like easy control, and it reduces the downtime because total time required for sterilization is short. And disadvantage is, if you are using this steam injection, there will be dilution and there can be also foaming. So, many times depending on the sensitivity of media, it is not possible to go for the steam sterilization, particularly when we are dealing with this animal culture media, because they have many nutrients, particularly these proteins, which cannot be exposed to the temperature. So, for that, for heat sensitive process, this microporous filters are used. The typical pore size is less than 0.2 micrometer, because the size of microbe we consider is in the range of 1 micrometer and above. So, with this microporous filters, we ensure that media is sterilized. However, it is not reliable as steam sterilization, because the apart from bacteria, other microbes cannot be ensured that they have been removed by this microporous filter. So, here we will be mostly focusing on this thermal sterilization. So, what it says, this high temperature and short time process. So, it simplifies the production planning and it allows the maximum plant utilization with minimum delay, and it provides the reproducible condition because this is a continuous process. Now, in the batch, the sterilization was done at 121, and here the temperature is increased to 140 degree centigrade, and therefore, the holding time, typically we keep the holding time of 21 minutes here. The holding time has decreased significantly to 1 to 2 minutes. So, that is why we go for high temperature and this short duration time, and it also requires the less steam because the time is short by recovering the heat from the sterilized media, and as it is a continuous, it is easier to automate the process. So, it is less labor intensive process. So, you can just see one process where continuous injection is done, your media and steam, they are continuously injected. Now, to achieve the certain temperature and the time, you need to have a holding section. Now, holding section here, let us say if you have reached the temperature of 140 degree centigrade, now you have to keep it for the, let us say 1 to 2 minutes. So, for that you need to have a holding section where continuously it is flowing. So, the sufficient length should be there particularly. So, how we will find the time? Time will be velocity length upon velocity, that is it. And then we are going to have this expansion valve where you can go have the flash cooler, and at the end you are getting the sterile media. So, here we are continuously injecting the steam. Other option is you are having the heat exchange type. So, what you are doing is, here your media is entering and getting not directly steam is purging, but getting heated through the heat exchangers. Now, in the heat exchangers, in one stage, if it did not reach to 140, it will go to the next step where steam is used as a heating media. Then it will reach to the 140 degree centigrade. Then again similar to the last slide, there will be holding section, and what is important here in the case of heat exchange is you are able to recover the heat, because this is the hot sterilized media. Now, it is utilized for the heating of, or rather is preheating of you can just see the raw media, then it is going to next heat exchanger, and further from here once it is cooled down, you are having the cooling water as a another fluid. So, this will be cooled down to the room temperature and sterilized media will go out. So, this is heat exchanger type continuous sterilization. Now, you can just see the steam injection type profile and heat exchanger type profile. In the both the cases, depending on the, in the case of steam sparging, it rapidly increases the temperature very short and quickly, the profile is very, then you have to hold for 2 to 3 minutes, then you go for flash cooling. And here it is taking bit longer time, close to about 20 seconds to reach to 140 degree centigrade, then holding, and then there is a exponential cooling time. So, depending on the, as we discussed earlier also, the heat transfer, the rate of heating and rate of cooling varies, and this is how we calculate the holding time, is defined as length upon velocity, and the sufficient length need to be provided to ensure the holding time of 2 to 3 minutes. So, this is all about this continuous sterilization. Now, we will quickly see in the bioprocess, as we require the air. So, air also need to be sterilized. So, the problem with the air sterilization is it is a bad conductor. So, once it is a bad conductor, so we cannot go for thermal sterilization. So, in aerobic process, this air need to be supplied and it requires the huge quantum of the air, particularly 0.5 to 1 volume of air per unit volume per minute. And as because of its poor thermal conductivity, sterilization by means of heat is economically impractical. So, for this the most effective way is the filtration using fibrous or membrane filters. So, when air is entering, we are using the filter to sterilize, and many times when off gases are leaving the fermenter, we also, the filters are also provided to sterilize the off gases when they are leaving the fermenter if it is required. And this is this gives the clear idea that what is the concentration of microbes in the air. It says the typical concentration of microbes in the air is 10 to the power 3 to 10 to the power 4 cells per meter cube. Now, we can have two different type of filter. One is called the absolute, means fixed pore filter, other is the Dept filter, non-fixed pore filter. In case of absolute filter, the pores of the filter are smaller than the particle to be removed, and here the pores in the filters are larger than the particle to be removed. So, how it is removed here? The removal of particle by inception on the surface and inertial impaction, diffusion and electrical attraction within the filter. And here, as it is a Dept filter, the removal is by the inertial impaction, diffusion and electrostatic interaction. So, there are different mode of removal. So, that is inertial impaction, diffusion, electrostatic attraction, that we will be discussing in the next slide. So, what it says, in the case of Dept, you are going to have certain thickness or X, which will ensure that sterilization is done, while in the case of absolute, you are having the pore in such a way that your microbes will not pass through it. Now, we can quickly revisit the theory similar to the thermal rate kinetics, but only difference here is it says dN upon dx, x is depth, it is not time, is directly proportional to minus k is the proportionality constant into n, and we will end up with n upon n naught equals to e to the power minus kx. X is the thickness of a Dept filter. And if you want to calculate what is the efficiency of filter, then n naught initial number of cell minus final number of cell into n naught, that is the efficiency And similar to this decimal reduction time, we can also write the x90 thickness required for the 90% removal. This will be the same 2.303 divided by where Kd is replaced by the K. So, similar to this cell death kinetics, we follow the theory of Dept filter. The only difference is time is replaced by the thickness, and this both the K and x90 they are dependent on the linear air velocity. So, we need to tune the air velocity in such a way to have the maximum value of K and this minimum value of x90. And these are the 4 different mechanism of filtration: inertial impaction, inception, diffusion and electrostatic attraction. So, we will quickly go through each of them. The first one is inertial impaction. So, inertial, as the name suggests, if there is a flow, so the particles are having certain velocity, and when the particle travelling in the air stream and passing around a fiber deviates from its air stream due to particle inertia, and it collides with the fiber. And once it is colliding, the impaction is dominant collection mechanism for particle at a certain size, particularly greater than 0.2 micrometer. And the efficiency of the inertial impaction increases with increasing the particle diameter or air flow velocity. So, basically this is there is certain velocity and the particle got stuck due to presence of a hurdle. The hurdle is the fiber here. Then once it got stuck, then there is no sufficient velocity for it to flow through it. Next is the inception occurs when a large particle, because of its size, collides with fiber in the filter that was passing through the air stream, and the inception mechanism is considered where particle has size but no mass. So, it says because of as there is no mass, so then there will be less force on it. So, it is purely, you can just see this is purely interrupted because of the size. The inception is dominant collection mechanism for particle greater than 0.2 micrometer, and again as it is based on the size, then particle collection efficiency by inception increases with increase in the particle size. So, first one was inertial impaction, second we have discussed is the inception. Now, third is diffusion. Diffusion occurs because of the random or Brownian motion of a particle, and because of that it contracts a fiber, and further diffusion is dominant for a particle less than 0.2 micrometer in the size for the smaller particle, and it may be important for the virus removal, but bacteria are sufficient large, the diffusion is relatively unimportant. So, here it says through the diffusion the smaller microbes can also be removed, and the collection efficiency by diffusion increases with decreasing the particle size or velocity. If it is very fast, then diffusion efficiency will be less. And last one is the electrostatic attraction. So, it is not applicable all the time. So, it will be only applicable when the fiber is having negative charge to that of the particle. The smaller particle are retained in the fiber by the weak electrostatic forces. So, this is done in many cases. Then if you can having a charge on your fiber, and you can induce the negative charge on the negative, or you can say you can induce the opposite charge on the particles. So, in this way I will stop here. So, today we discussed about the batch sterilization and the continuous sterilization of liquid media particularly. So, in the case of batch sterilization we are going to have heating section, holding section and cooling section, and in the case of continuous sterilization all three sections are too small. It means it is very rapid heating, holding time is only 2 to 3 minutes, then there is a flash cooling. And there are two type of continuous sterilization we discussed, direct steam spurging or heat exchanger type, and followed by that we discussed the air sterilization, particularly using the Dept filter, and we also discussed briefly that what are different mechanism for air sterilization. So, I will stop here. Thank you.